Morning, guys. Sorry I couldn't be here with you today, but hopefully through just watching this video lesson, I'll be able to answer any questions that you have about your notes from day one. Make sure that you also take some time today to do your bell ringers for day one from this unit. Tomorrow, the things I'm going to be checking are your homework from day one, and then I'm also going to check to make sure that these notes are completely filled in. So make sure you use your class time wisely. And we should be able to pick back up when I come back tomorrow, okay? We talked a little bit about congruent figures in the last unit with how rigid transformations like translations, rotations, and reflections produce congruent figures after we transform our shape. So in a sense, if we just want to define what does it mean to be congruent, this would mean that the shapes are the exact same. More specifically, this would mean that the angles have to be the same measure and the side lengths would have to be the same measure in order for everything about the shape to be congruent from the pre-image to the image, okay? We also talked about the term corresponding back in Unit 3 when we talked about parallel lines and transversals. Remember, with parallel lines, corresponding kind of just meant in the same position. So like top right, top right. It means a similar definition when we talk about congruent figures, in that if sides or angles are corresponding, it essentially means in the same position relative to their shape. So, for instance, if I had two triangles and they're both oriented the same way, when I talk about corresponding, I would mean both top angles, or I would mean both left sides. Okay, so just think corresponding, same position. So again, we talked about in the last unit rigid transformations producing congruent figures. So this first question says if the quadrilateral ABCD was rotated clockwise around point E so that it would form WXYZ as its image, what sides would be corresponding? So if we think about AB, the top short side would have rotated around to become the same side as WX. So AB, WX would be a pair. BC and WZ would be a pair. AD and XY would be a pair. And then ZY and CD would be a pair, just following where they are position-wise. Same thing goes for the angles. If we're looking at what angles would be corresponding to each other, angle A would have rotated around to be in the same position as angle X. Angle B would be in the same position as angle W. Angle C would be corresponding to angle Z. And angle D would be corresponding to angle Y. So in short, two polygons are congruent if and only if I can say that their corresponding sides and corresponding angles are the same. So two polygons are congruent if and only if I can say that about the entire shape. All their corresponding sides and all their corresponding angles have to be congruent to each other. So there are two different ways you can be told that two figures are congruent. One of which is if you're just given a congruency statement. If we're given a statement, you just need to follow the order of the way the figure is written. So the order indicates what parts should be corresponding and therefore congruent. All right? So if we have triangle ABC is congruent to triangle DEF, angles-wise, if angle A is listed first, then its corresponding and congruent partner would be angle D. Angle B would be corresponding to angle E, and angle C corresponding to angle F. Similarly with your sides, when we list the sides that are corresponding, follow the order. A to B would be the same as D to E. from B to C would be corresponding and congruent to EF. And then for that third side, you could write it one of two ways. You could say A to C and D to F. Or if you went the other direction and said CA, you would need to follow with FD. The point is just make sure you keep everything in the same order. All right. If you are given a diagram, and I meant to have all of this already marked before I printed these for y'all, I apologize. So take a second and mark these if you need to. But what we're looking for with a diagram is you'll be given a picture with all of that already added, and you're looking for which angles and which sides have the same markings, just like we've been doing all semester. So if that were the picture I had, I'm looking for marks of angles that would indicate congruence. So angle R would be congruent to angle Y. Angle Q would be congruent to angle X. Angle S would be congruent to angle Z. And then the same thing for the sides. You're looking for sides that have the same marks. So Q to R would be corresponding and congruent to X to Y. One thing you want to make sure when you're listing sides like this is if I go from Q to R, angle-wise, I'm naming 2 to 1. So when I go to name this side, I need to also go 2 to 1. So XY instead of YX. All right, R to S would then be congruent to YZ. And then QS would be congruent to XZ. All right, and we're just looking for, skip this blank, looking for the markings. Okay, the little kind of tick marks, the little curves inside the angles that indicate congruency. All right, so I'm actually going to leave example 1 blank. You guys can go through and practice just identifying all the pairs of corresponding parts. If I have a triangle, I should have 6 parts total because you have 3 sets of angles and 3 sets of sides. If I have a polygon with 4 sides, I should have 8 total, 8 angles, 4 sides, 4 angles. And then same thing for 3, but then also kind of review from last unit, what transformation could I have used to map ABC onto XYZ? All right? So you can always go back and fill those in, practice on your own. For this next set, it wants you to write a congruency statement given that the figures are already congruent. So there are lots of different correct answers that you could have for a question like this. The point is when you're done and I read your answer, all of your angles should match in the same order. So the easiest way to do it is to pick one of the triangles and name it. So let's say I name this one ZXY. When I go to name this second triangle, I have to name it in such a way that all of the parts come in a matching order. So if Z has 1 mark, so does H. If X has 2, so does I. And then if Y has 3, then this Y also has 3. So that when I read back through your answer, all of these parts should match in order. All right. You could have also, though, named this triangle maybe XZY, YZX, YXZ, etc. However you name it, you just need to make sure you name the second one in the same fashion. Okay? So for 5, for instance, I could say triangle XVW. And then I would name my second triangle JKL, so that the parts come in a congruent and corresponding order. And then maybe for 6, if I name the left triangle RFQ, I would say that is congruent to HFG. All right? But again, lots of different options there, just as long as when you read back through your answer, everything is in order. All right, applying a little bit of that to kind of some algebra review. So it says in the figure shown, GJIH is congruent to MNKL. Find the values of both X and Y. So when you look at your picture, one of the first things I notice is that I can't use this expression right now because it has both a missing x and a missing y. Those are too many variables to solve for at once. So the easiest thing to do would be to figure out what I could compare this to. So based on your congruency statement, I know that KL, that side should be the same as I to H. So that side length should be the same as 12. So my first step would be to compare those. So if 2x minus 4 is equal to 12, solve that out, not 4. We get that x is equal to 8. Now that you know that x is equal to 8, you could always go back in and rewrite that expression, 6y plus x, just fill the 8 in. Then I can work with that. So now I'm looking at how this angle, LKN, should be the same as angle IHJ. So secondly, I know that 6y plus 8 should be the same measurement as the angle that's 68 degrees. So then 6y would equal 60, y would equal 10. Okay. Same type of setup for the second one. If I'm given that triangle ABC and triangle DEF are congruent, find x and y. So what I would look for in this case is I notice that angle EDF, again, if I were to follow this congruency statement from E to D to F, should be the same as angle BAC, kind of if I'm looking at the order of the letters. So those two should be congruent. So 87 degrees is the same as 5x plus 2. 85 would be the same as 5x. And then if we divide 85 by 5, y'all can work that out. For the second one, same thing. Angle EFD should be congruent to angle ACB. So if 42 and 3y should be congruent, go ahead and divide out the 3, and y'all can work out what y is equal to. Okay?